All right, this is Ubaid on behalf of B Electronics, and in this video, we'll be looking into derivatives. Okay, now when it comes to derivatives, derivatives has to do with change. Okay, so anytime you have a change in something, it has to do with a derivative. Okay, so for example, you have a change in the slope of a line. Okay, so that would be an example of a derivative. Okay, so if the line, for example, looks something like this. Okay, let's say this is a straight line. Okay, and all of a sudden you have a change in the slope. Okay, so this would be an example of a derivative. Okay, so basically you can use the derivative of an equation to find a certain slope, for example. Okay, so let's take an example over here. Okay, so let's say this is your equation, y equals 2x squared plus 2x plus 5. Okay, so now if you want to solve and find the derivative of this equation, okay, all you will need to do is multiply the exponent by the coefficient in front of the base. Okay, so this is your base, x, coefficient is 2, so 2 times 2 is 4, x all raised to 2 minus 1. Okay, so you'll subtract 1 from whatever number you have for your exponent. Okay, plus same goes with the second term over here. So let's say this is x raised to 1. Okay, so this will become 2 into x raised to 1 minus 1. Okay, so this is basically how that works. All right, and plus 5. Okay, this does not count, which means we'll leave it as it is. All right, so y equals 4x raised to 2 minus 1. This will be 4x, okay, or 4x raised to 1 plus 2x, 1 minus 1 is 0, x raised to 0 is 1, 1 into 2 is 2. Okay, all right. So this is basically how you solve for this equation. Okay, the solution will be y equals 4x plus 2. Okay, let's take another example. Okay, let's say this is y equals 4x raised to 4 minus 2x plus 9. Okay, to solve this equation over here, you will need to multiply 4 by the coefficient over here in front of the base. So let's say this is 16. Okay, 16 x raised to 4 minus 1, which is 3, or x cubed, minus 2. Okay, so 2x raised to 1 minus 1. So this will become x raised to 0. Okay, so on and so forth. So this becomes y equals 16 x cubed minus, this is basically 2 into 1, which means your solution is y equals 16 x cubed minus 2. All right, you can always sub in values for x as well as y to solve for either x or y. Okay, so, okay, in terms of real world application, okay, let's take an example over here. Okay, let's say the slope. Okay, you will need to find the slope, and let's say you need to find the slope of the curve y equals 4x cubed minus x, for x equals 3. Okay, so in order for you to find the slope, first of all, you will need to write this in an equation format. Okay, which means you will need to write an equation for the word problem over here. Okay, so y equals 4x cubed minus x. All right, so this will be y equals, okay, 4x cubed minus x, which means that this will become 12. Since we're trying to figure out the slope or the derivative of this equation, this will be 4 times 3, 12, x squared, minus x raised to 1 minus 1 is 0, which means this will be 1. Okay, so x equals 3. We've been given the x value. So this will be x squared minus 1. Okay, which means that y equals 12 into 9 minus 1. This will be 108 minus 1, which becomes 107. Okay, so your slope is 107. Okay, the voltage V produced by a certain thermocouple as a function of the temperature T is given by V equals 4.0 T plus 0.005 T squared. If the temperature changes slowly, find the rate of change of voltage with respect to temperature when the temperature is 200 degrees Celsius. Now, before we solve for this problem over here, we'll need to arrange this. We'll need to figure out the equation for this problem. Okay, so we know that V equals 0.005 T squared, okay, plus 4.0 T. Okay, now if you want to solve for this equation, okay, what you will need to do is you will need to find the derivative. Okay, so we know that the derivative is going to be 2 into 0.005 T, okay, plus 4 into T raised to 1 minus 1, which is basically 0. So 2, okay, into 0.005 T. So we know that T is 200 degrees Celsius. So what we will do is we'll sub in this value, 200 degrees Celsius. So this will become 2 into 0.005 into 200 plus 4. Okay, so let's do an example over here. So this will be 2 into 0.005. This will be 0.01. So this is 0.01. Okay, into, okay, 200 plus 4. Okay, so 200 into 0.01. This will become 2 plus 4. This will be 6. Okay, so this will be 6 for your solution. Okay, so if the temperature changes slowly, find the rate of change. So this will be, okay, okay. All right, so this will be 6 volts per degree Celsius.